this animation, I'm going to go through a DNA sequencing method known as the Sanger method or the dideoxy chain termination method. The requirements for this method are template strand DNA, which is used as a known fragment of the DNA to be sequenced, free nucleotides, which are used for the elongation of DNA, oligonucleotide primers, which are used as a starting point for the addition of nucleotides through enzymatic synthesis, and DNA polymerase, which carries out enzymatic synthesis. Once all of these ingredients are mixed together, they're separated into 4 different containers. And into each of these containers, one specific nucleotide analog is added. And these will selectively incorporate themselves into the DNA fragment in place of their nucleotide counterparts. DNA nucleotides are also known as DNTPs, or deoxyribonucleotide triphosphates. The deoxy prefix refers to the 2' hydroxyl group which is missing from the ribonucleotide. Their analogues are known as DDNTPs, or dideoxynucleotide triphosphates, and the dideoxy prefix refers to the lack of both the 2' and the 3' hydroxyl group. The 3' hydroxyl group is important as nucleotides use them to polymerize through phosphodiester bonds. Since the analogues contain the same phosphate groups as the regular DNA nucleotides can polymerize with them through phosphodiester bonds. However, since nucleotides lack the 3' hydroxyl group, they cannot polymerize with other nucleotides. So, if a DNA fragment polymerizes with an analog, that will bring polymerization to a standstill, terminating it. Since these analogues are only selectively incorporated into the DNA sequence, you'll get a wide variety of lengths of DNA fragments, which will give you an idea of the wide variety of positions a certain nucleotide will be in a particular DNA sequence. The analogues are identified through radioactive labeling of their alpha phosphate group, as that's the group that takes place in the phosphodiester bond. Either the phosphor atom is replaced by a phosphor isotope, or one of the oxygens attached to the phosphor atom is replaced by a sulfur isotope. High-resolution electrophoresis is then carried out on DNA fragments to separate them down to a single nucleotide. Each DNA solution is placed into a different well depending on which analog was added to it at the beginning of the experiment. As the radioactively labeled analogues emit beta radiation due to their isotopes, they form a black band on X-ray film. As these black bands accumulate on an X-ray film, they form a ladder, and from this ladder we can determine a particular DNA sequence. The Sanger chain termination method can be used to determine DNA sequences up to 800 nucleotides long.